Now the first rule here is for the elementary state, the oxidation number will be 0. Now the term elementary state means if an atom is by itself or a gas is by itself, or when atoms combine with itself, then this two condition is termed as elementary state. For example, if we have sodium, copper, potassium, iron, now these are in the elementary state and these atoms will have the oxidation number, that is 0. And if we consider about the gas which is by itself, for example, if we have hydrogen, nitrogen or oxygen, then in this case also the oxidation number will be 0. Now the atom, when it combine with itself, let's take an example of sulfur, phosphorus. Now in this case is also the sulfur atom, each sulfur atom is combined with itself, and in the second case 4 phosphorus atoms are combined with itself. So in this case also the oxidation number will be 0. Now the second rule, in case of hydrogen, the oxidation number is bifurcated into two cases, that is with metals or with non-metals. So with metals, the oxidation number of hydrogen will be taken as -1, and with non-metals the oxidation number will be considered as +1. We have lithium hydride or the potassium hydride. Now lithium is a metal and potassium is also a metal. Now in this case the oxidation number of hydrogen will be -1. Now if hydrogen is combined with non-metals, for example we have water molecule or hydrogen sulfide, we know oxygen is a non-metal and sulfur is also a non-metal. So in this case the oxidation number of hydrogen will be considered as +1. Now for oxygen there are 3 cases. So 3 cases will be considered for in the case of oxygen. Now the first is in the oxide form, the second is peroxide, and the third is superoxide. Now the oxidation number in case of oxide will be -2. In case of peroxide the oxidation number will be -1, and for the superoxide the oxidation number will be -half. So let's see the 3 cases. For the oxide, let us suppose we have sodium oxide. Now in this case the oxidation number of oxygen will be -2, or if we have potassium oxide also, then in this case the oxidation number will be -2 for the oxygen atom. Now for peroxide, let us take an example of hydrogen peroxide or sodium peroxide. Now in this case the oxidation number will be -1 for the oxygen. Now for superoxide, let us take an example of NaO2, and the oxidation number will be -1/2 for the oxygen atom. Group first elements, that is alkali metals, the oxidation number will be considered as +1. All these elements will have the oxidation number that is +1. Now the group second elements are called alkaline earth metals. And the oxidation number for the alkaline earth metals is +2. Now all these elements belong to group second, so they all have the oxidation number that is +2. We have two cases for the compounds, that is a neutral compound or an ionic compound. So in case of neutral compound, the summation will be equal to 0, and in case of ionic compounds, the summation will be equal to the ionic charge present on the compound. Now for example, we have water molecule or ammonia gas, then the overall charge on it will be 0. Now there are two cases for the ionic compounds, that is cation or anion. So if a compound has a positive charge on it, equal the charge by +1, and for potassium also we will equal the charge by +1. And for the anion, suppose we have sulfate ions or the nitrate ions, then in case of sulfate we will equal the ions by -2, and for the nitrate we will put a equal sign and make it equal by -1. For the halogens, the oxidation number is -1. So for fluorine, chlorine, bromine, iodine, the oxidation number will be -1. So let's find the oxidation number of the underlined atoms. Now the first is water molecule. We have 2 atoms of hydrogen and 1 atom of oxygen. Now 2 atoms of hydrogen and 1 atom of oxygen, and the oxidation number of hydrogen is +1, so we will multiply it by 2, and we have to find for the oxygen atom, so we will consider it as x, then multiply the 2. Now when 2 is multiplied with +1 we get +2, and we will make it equal to, now +2 and +x will be equal to 0 because water molecule does not have any charge on it. It is a neutral compound, so we will put 0 in front of this equation. Now we get the value of X, that is -2. So the oxidation number for the oxygen in this case is -2. Now the next example we have to find for the sulfur atom. Now the oxidation number for hydrogen is +1. We have to find for the sulfur, and the oxidation number of oxygen here is -2. So 2 atoms of hydrogen, 1 atom of sulfur and 4 atoms of oxygen. Now putting the oxidation number of hydrogen, that is +1. We have to find for the sulfur, let us consider it as X, and 4 atoms of oxygen, and the oxidation number for oxygen is -2. So by solving it, we get X -6. Now we will put, now we get X -6 and put equals to sign, and now the whole equation will be equal to 0 because sulfuric acid does not have any charge on it. So we get X, the value for sulfur here is, the oxidation number of sulfur is +6. Now the next compound we have is potassium dichromate. Now the oxidation number for potassium is +1. For chromium we consider it as X, and for oxygen we have -2. So 2 atoms of potassium and 2 atoms of chromium and 7 atoms of oxygen, and the summation will be equal to 0 since it is, the compound is not having any overall charge on it. The oxidation number of potassium is +1. For chromium we have to find it, so we are, and 7 atoms of oxygen, that is -2. Now this summation will be equal to 0. Now we have 2x -14 equals to 0, and 2x -12 equals to 0, 2x equals to 12, then 12 by 2 we have +6. So the oxidation number for the chromium here is, we have +6. Now the another compound we have is nitric acid. So we have 1 hydrogen, 1 nitrogen and 3 atoms of oxygen, and since there is no overall charge on the nitric acid, so the summation will be equal to 0. Now the oxidation number of hydrogen is +1. We have to find for the nitrogen, and the oxidation number for the oxygen atom is -2. So 3 atoms of oxygen. Now we have +1, then X, then -6 equals to 0, X, then -5 equals to 0. Now in this case the oxidation number for nitrogen is +5. Now the next compound we have is sulfate ion. In this case we have 1 atom of sulfur, 4 atoms of oxygen, and the summation will be equal to -2 because the overall charge on the compound is -2. Now to determine the oxidation number of sulfur, let us consider it as X, and 4 atoms of oxygen, that is the oxidation number of oxygen is -2. Now the summation will be equal to -2. Now X minus 8 equals to -2. X equals to -2 plus 8. X equals to plus 6. So the oxidation number of sulfur here is plus 6.